Crude oil is a versatile natural resource with various uses that are essential to modern life, providing the raw materials for fuels, plastics, chemicals, and many other products. However, crude oil in its raw form is a complex mixture of hydrocarbons that must be processed and refined to create useful products. One of the key processes used in the refining of crude oil is cracking, which involves breaking down long-chain hydrocarbons into shorter, more useful molecules. Cracking is important because the longer-chain hydrocarbons, such as those found in heavy oils, have limited uses and are less valuable than the shorter-chain hydrocarbons, which can be used as fuels like gasoline and diesel or as feedstocks for the petrochemical industry. Cracking works by splitting up large, complex hydrocarbons into smaller molecules through the application of heat, pressure, or catalysts. Long-chain hydrocarbons, which are composed of many carbon atoms, are less flammable and have higher boiling points, making them less suitable for use as fuels. By breaking these long chains into smaller fragments, cracking produces shorter-chain hydrocarbons that are more flammable, more volatile, and have lower boiling points, making them ideal for use as petrol, kerosene, and other fuels. Cracking also produces alkenes, a type of unsaturated hydrocarbon that is highly reactive and used as a key building block in the production of plastics, synthetic rubber, and other important chemicals. There are different methods of cracking, each with its own approach and benefits. The most common methods are thermal cracking and catalytic cracking. Thermal cracking involves heating the long-chain hydrocarbons to very high temperatures, often between 450 and 750 degrees Celsius, causing the molecular bonds to break. This process can be performed under high pressure or in a vacuum. Thermal cracking is effective at breaking down heavy hydrocarbons but can produce a mixture of products, including both alkanes and alkenes, depending on the conditions used. Catalytic cracking, on the other hand, uses a catalyst to lower the temperature and pressure required for the cracking process. In catalytic cracking, the long-chain hydrocarbons are vaporized and passed over a catalyst, such as zeolites, at lower temperatures, typically around 450 to 500 degrees Celsius. The catalyst helps to break the bonds more efficiently, producing a higher yield of shorter-chain hydrocarbons, particularly those useful as fuels like gasoline and diesel. Catalytic cracking is favored in the industry because it is more efficient and produces more valuable products, including high-octane petrol and olefins like ethylene and propylene, which are important for making plastics and other chemicals. There is also a method called steam cracking, which is used primarily in the production of ethylene and other alkenes. In steam cracking, the hydrocarbons are mixed with steam and heated to extremely high temperatures, around 800 to 900 degrees Celsius, without the use of a catalyst. The high temperatures cause the long-chain hydrocarbons to break apart into smaller molecules, producing a high yield of light alkenes, such as ethylene and propylene. These alkenes are critical raw materials in the manufacture of a wide range of products, including plastics, solvents, and synthetic fibers. Through cracking, refineries can transform less valuable, heavy hydrocarbons into lighter, more valuable products that meet the high demand for fuels and chemical feedstocks. This process allows for more efficient use of crude oil, maximizing its potential and ensuring a steady supply of the fuels and materials that power our vehicles, heat our homes, and are used in countless everyday products, from packaging and textiles to pharmaceuticals and cosmetics. Cracking is, therefore, a crucial process that enhances the utility and value of crude oil, making it an indispensable part of modern life and the global economy.